We have 3 minutes left until our webinar starts with the National Space Center, and they have a special guest today, Dr. Kanani, who is an expert astronomer, and we're hoping that she'll answer Elizabeth's question. Right, Elizabeth?
My question.
Your question about gravity. Huh, Elizabeth? About gravity. Yeah. Yep, she's going to answer your question, we hope. We will wait and see.
Astro Liz, who's age 7, I think she likes space, I get from the name, would like to know how gravity creates waves and if there is an experiment to demonstrate the concept. So Sheila, can you help?
Yeah, I mean, this is a really good question, and it's going to addle your brain a little bit, but bear with me. Okay, so imagine that space is the surface of a trampoline. And that's where these gravitational waves are going to occur. So we've got our surface of our trampoline, slightly stretchy and bendy, and then you put a big bowling ball on top of that trampoline, and the surface of that trampoline will start to dip because that bowling ball is heavy. What that's representing is the bowling ball is a massive object in space, like a star or a black hole or something like that, and the bending of the surface of the trampoline is the effect that gravity has on space. So gravity can affect space, it can squeeze and stretch space, particularly when two really massive objects either collide or interact with each other. So imagine you've got two black holes, both of which their gravity is so strong that even light can't escape from these black holes. And they're orbiting around each other in this sort of dance. And because their gravity is so massive, they're able to bend and stretch the surface of the trampoline. They're able to cause these ripples in the surface of space and time, and that's what we call gravitational waves. And we're able to measure that rippling, that bending and that stretching using lasers. So there's an observatory called LIGO, which has two arms stretching out, and lasers coming off of those, measuring the surface of this trampoline in space, measuring these stretching and these bending and these slight ripples. A bit like if you have, so you might have a tape measure at home that you can pull out and you can measure the length of a room. And a modern version of that is a little box with a little laser that points to the end of your room, and then some numbers will come up on your box telling you how big your room is. So imagine a laser tape measure in space measuring how this gravitational waves are stretching and squashing the fabric of space-time. I don't know if that answered your question, but that's kind of what it is.
No, I got that, and I love the idea of a trampoline. We have we use stretchy fabric with a hula hoop and put a weight in the middle of it to sort of to show that, because unfortunately they don't give us trampolines at work. Otherwise, I don't think any of the office staff will get any work done. We'd all be on the trampolines all day. But no, that's certainly brilliant. Thank you very much.